Today's topic is radian measure. This is part of our circle unit, which is unit 8. So you can put today's date on your notes, 4/17. And this is the note packet that you'll need. Many of you have asked me if I had posted this video, and here it is. So a radian is a different type of angle measure. Next year in Algebra 2, you're going to explore this very deeply. But basically, what we're creating is a central angle. So we know that that's drawn from the center of our circle. We'll have our two radii as the borders. And when the central angle intercepts the arc, the length of that arc is equal to the length of the radius. So you can see in my picture, the radius is highlighted in red. This blue arc is the intercepted arc, but both the blue and the red are equal. So that would be equivalent to 1 radian. The angle measure for 1 radian is a little bigger than 57 degrees. If this is our central angle, theta represents our radian measure for the angle. We can see our radius, and S is our intercepted arc. So let's go through each of these symbols. This is the formula that we use to calculate the measure of theta in radians. So again, theta will be our angle measure. Remember, it has to be a central angle. S will represent the length of the intercepted arc, and typically this is in some kind of linear measure, inches, feet, meters. And R is the length of our radius. So if we have our circle O, and the center of this circle is going to be the red O, we can draw the radius, R. And then if I draw it on the other side, I'm creating the diameter. So when that is occurring, we're separating our circle into 2 equal halves, or 2 semicircles, each of which will have 180 degrees. We also know that the semicircle's arc also has 180 degrees. But if I were to convert 180 degrees into radians, what would the measure be? So let's explore this a little bit. I know that 1 radian has approximately 57 degrees. So let me draw that on my diagram. So that looks about right. Well, I haven't made it to 180 degrees, so I'm going to draw another section, another radian. I still haven't made it. We're going to draw a third radian, and I'm close, but I haven't made it to exactly 180 degrees. So there's a little bit left to go. So right there is 3 full radians in each slice of that pie. So we do need a little bit more to come up with an exact value for 180 degrees. So let's think about this. How much is left to get to 180? Well, I've used 171 and a little more degrees. That leaves me a little over 8 degrees to get me to exactly 180. So what portion of another radian would I need to get me to 180? So we're going to set up a ratio. We have the remaining number of degrees in the numerator and the number of degrees in a full radian. And when I do the division, I will get a percentage. If you look at that number, 0.14159, hopefully that will seem familiar. So I have used 3 full radians, 3, and then I need 0.14159 of another radian. So if you're putting this together, what you can see here is that 180 degrees is the equivalent of 3.14159 radians, which is the value that we use for pi. So this is where that number comes from. And radians are more accurate than degrees. Higher level mathematicians will always do their calculations in radians. So there we go. A semicircle, or 180 degrees, has the value of 1 pi radians, which is 3.14159. if I make it all the way back to the beginning and I go another 180 degrees, I will have traveled 2 pi radians. So 1 pi radian and 2 pi radians will have significant value as we move forward. So we know that when we draw in our diameter, we are creating 2 semicircles. Each semicircle has an arc length that is half of our circumference. So we could always use our circumference formula to calculate a linear measure or the distance. There is a lot of space here for you to write. We were going to go through the theory, but to save time for the video, we're going to skip the theory. It's not really relevant at this time. So what we want to do is convert between radian measure and degree measure. It's actually pretty simple. So if you're provided a measure in degrees, you're going to follow the path. We're going to multiply by pi over 180, and that will produce a radian measure. If you have a radian measure, we're going to multiply, we're going to follow the arrows, by 180 over pi, and that will give you a measure in degrees. So the calculations are pretty simple. If you want to try any of the examples on your own, remember you can pause the video. We're going to start by converting 75 degrees to radian measure. So if you recall from the last slide, what we want to do is multiply by pi over 180. The value of 75 over 180 will be a fraction, and it will reduce, and we should always reduce our fractions to lowest terms. And the pi will stay present. So 75 degrees is equal to 5/12 pi radians. Just so you know, we leave the fraction intact. We never ever convert it to a decimal. The fraction is the more appropriate. If you don't want to leave pi in the numerator, you can pull it so that it's separate from the fraction, but it should be either on top or in the middle. So you could say 5/12 pi radians with them separated. Okay, let's convert 135 degrees. Remember, if you want, you can pause and see if you can do it on your own. We're going to multiply, though, by pi over 180. And I usually just type 135 divided by 180 into my calculator, and I let it reduce for me. And that will reduce to 3/4 pi. So 135 degrees is 3/4 pi radians. We're now converting 105 degrees. It should be a little bit smaller than my last answer. So again, we're multiplying by pi over 180. And when I reduce that on the calculator, I get 7/12 pi radians. In our final example for this style, we're going to convert 240 degrees. If you think about what we had done with our example, we know that 180 is equal to 1 pi radian. We're going beyond that because we're traveling past the 180 mark into the next quadrant. We're still going to convert it the same way, but just know that your fraction will no longer be a proper fraction. It's going to be an improper fraction, usually greater than 1. So if I put in 240 over 180, it will reduce to 4/3 pi. And I know 4/3 pi is greater than 1. So I've gone past the halfway mark and I'm working on 2 pi radians. I'm trying to head back to 360. Now, if you want to go the opposite way, we want to convert a radian measure to degrees. We have 1/4 pi radians. We're going to use the opposite value. So we're going to multiply pi over 4 times 180 over pi. And again, you can use the diagram and follow the flow of the arrows. When you have your fraction set up, it's easy if you simplify the things out that will go away. And pi, they're diagonal, so those will cancel. So I crossed them off here, and really the answer will be 180 divided by 4, and it's 45 degrees. Let's try that again in our next example. We're going to convert 7/3 pi radians into degrees. I do know that it should be greater than 180 because my fraction is improper. So let's set this up. We're multiplying our radian measure times 180 over pi. Again, the pi's will cancel. And then we're going to multiply 7 times 180 and then divide that answer by 3. Be careful with the calculator or the iPad that it doesn't misunderstand the order. And we have 420 degrees. So we are greater than 180. In fact, 7 over 3 is greater than 2. So we've gone beyond 360 and we're moving back around for a second rotation. In the last example of this style, we're going to convert 17 over 6 pi radians into degrees. Looks like I have a typo. Instead of multiplying by 180 over pi, there is another method. I know that pi is equal to 180 degrees. So let's substitute 180 in for pi this time instead of multiplying by a fraction. So this is what it will look like. And again, don't let the calculator be confused by the order you wish to calculate. And I have 510 degrees. Our last example is more of a word problem, and you'll see a lot more of these in Algebra 2. But it says in a circle, the length of a radius is 4 centimeters. Find the length of an arc intercepted by a central angle whose measure is 1.5 radians. So if we go back to earlier in the lesson, we have the measure in radians, theta, is equal to S, our intercepted arc, divided by R, which is the radius. So I'm going to sub in the pieces that I know. So I know that the angle measure is 1.5 radians. My radius is 4. The intercepted arc is S, and that's what I'm looking for. If you wanted to make this a proportion, you could put 1.5 over 1. But basically, I'm going to multiply 1.5 times 4. And my intercepted arc is 6 centimeters. And again, that is a linear measure. Our homework is actually number 109. This seems like it's a little bit out of order. It's just that I had skipped it in the first round. But you'll see that it looks like this. We're going to do problems 1 through 37 odd. You do not have to do all of them. And then when we get to 39 through 44, that's when you're going to do all the problems. Please show me all the work involved in your conversions. If you have any questions, please make sure you either call me at home or on my cell or send me a text or you send me an email. Remember, this quarter is a little bit different. We are grading now, and failing grades are a possibility if you don't stay on top of your work. Have a great day.